I try to define why digitalization is needed and how can it improves the construction domains, the capabilities. And also we'll look into a new technology called ontologies and semantics and how are they trying to help to achieve this goal. And I also try to give a small introduction about our company and what we are doing to gain the advantage of this research and to have the autonomous construction and so on. At the end, I will give you insights about this AI technologies we are using at the moment in the industry and how we are generating the insights from the data. Yeah, before I jump into the actual presentation, here is a small teaser about that. So I try to take you to a brief discussion about a diversified construction domain and how this diversified construction domain can be improved through the collaborations and an efficient sharing of information among the engineers in the construction domain. And how do we take this into a practical application? So how can we make everything feasible? Yeah, before start to the background, I just prepared a small interactive session. So I know it's very active today. Let's take a step back and try to chill and just to feel an icebreaker. I hope you can see this Miro, or it's called Mentimeter. So maybe you can join by either by scanning this QR code or going to the menti.com and providing this use code so that we can small interactive and try not to be have frequently asked questions. Could you, yeah? Is there any trouble or could you join? Yeah, just give me a thumbs up or something if you can join. Yeah, fastest fingers fast. I have only limited seats in this. So I guess only first 50 people can be accessed into that. I would recommend to be fast. Yeah, I just wait a minute. If you join already, you can also join during the process. I just ask one small icebreaker. Yeah, I know you are in a session until now. Maybe if you just sit back, relax, and if you can answer this question, like one food you could eat for the rest of your life. Maybe it's just a what question, you can just type. Yeah, you can go to the menti.com and then you can use this code to join. You can answer this question by that. Yeah, I hope you have no trouble to access it. Right? So one answer, I see pizza. No worries. Let me go to my next question, where I would like to check how about the different terms, how aware about this. Maybe if you can give your answers on this, like have you heard about the terms below before, right? Have you heard about the term building information modeling? Have you heard about the term called IFC, Industry Foundation Classes? Something called ontology or anything called LODs, level of developments? Right. Yeah, I see one response. I'm happy to see at least one. Yeah, let me just go back to my presentation and try to give a bit more detailed information on these topics. Let me take out this. Let's jump into the background, a problem statement. So as I mentioned that we are going to talk about the diversified construction domain. Yeah, and you hear that perhaps you might have been experienced in your working life. So the construction domain is a quite complex and it involves a lot of engineers and so many design perspectives and so much of creation of these design models and sharing of data among these engineers and so on. So this creates this complex nature of the diverse construction domain is always seeks you to recreate the existing data. So the recreation of this existing data is always a time consumption activity, and it may cause us to a prone to errors, and due to the lack of this collaboration and how the data is shared among them, this has also result in the poor planning. What do I mean about poor planning or difficulty in a collaboration, right? Let me take a sample example scenario, and I would walk you through this example. Let's take a simple example like where Bob wants to construct a residential building, and for that he hires an architect or a construction firm, and he try to explain his needs to this architect or a construction firm. So what are his needs? He wants to construct a 6-floor building where the ground floor would like to be for a commercial purpose, for example, shops and so on. And he would like to spend a amount of budget on this construction, and he wants to finish this construction at this duration. Once his requirements has been placed, and the architect is trying to understand his requirements, and based on the requirements from an owner of a building, so the architects will come up with an architectural plan. So he takes a tool one, and whatever it is a tool, and he try to develop an architectural design model by digesting the requirements from the owner. I think this is a starting point of our construction design. Once an architectural design has been produced, this has been shared to the multiple other engineers where they check the design or they improve the design in terms of safety and comfort. Here I take an example, energy simulation and structural design. So this architectural information has been shared to these two other design engineers where they want to improve the initial design. For example, energy analyst uses some tool too, and then he try to see how much is the consumption of energy and how is the natural light and so on. Yes, it is already a red flag we see here. It is already a recreation of a data, what architectural model design has, and the other engineers needs to be regenerate the same information in different tools. As I mentioned that this is a highly time consumption, at the same time also prone to the human errors. This is not the end of a design, so there is always a design changes. For example, maybe the orientation of a building is not set properly so that the natural light is not coming inside the building, so that they need an artificial lighting solutions. To enhance that, energy analyst send back his feedback, and then they say you need to rotate the building by these degrees so that you will get the natural light and you don't need to have the artificial lighting. The same process could be done from the structural designer side, right? He can say that, hey, the distance between two columns are quite large and it is producing the large beams, and I need to place another column, you had to divide your spaces according to that. So this information has always shared between multiple engineers, and the other one is not know what is happening. And his design progresses with the assumption of what is not changed in the initial cases. And this communication is not end at one engineer. Perhaps in energy and engineers and structural designers also need to be communicate among them, so that they had to try to design their piping systems or the ducting systems according to that. Yeah, and once we are also having these cases, right? Once your design is also freezed, it is always unnatural that this has been constructed as it is. There could be many problems in the site. Your model or your design sizes are suitable, scaffoldings are not available at the site, so they had to adapt according to the site constructions. Here is again the second red flag, where the collaboration among these participants in the domain is very complex. So this causes a lack of information loss and repetition, and at the end, a lot of time consumption, which leads to the poor planning and poor budget allocation. That's where comes the building information modeling. You might have been heard about that. This is a business process where it tries to manage the data among the engineers and to bring an efficient collaboration among them. Yeah, let's take a simple example and try to understand a bit better, right? Yes, there is a research group called Building Smart Semantics. So they had come up with a neutral file format, which is called IFC, which is an industry foundation classes. So an architect designs his architectural model in any of the CAD models like Revit, Navisworks, anything, and he can share it to the other engineers through this IFC file format. So the other engineer does not need to remodel his building from the scratch. He can simply import this file into his tool, and then he can start from the scratch. I mean, his design cases. Let's let's dive into this building information modeling through the another example scenario. Now we call Rob. He's a friend of Bob, and he wants to also construct a building. But he wants to get suggestion from the Bob because he had experienced previously this diverse construction process. And according to suggestion from the Bob, and he wants to go with the BIM-based construction approach, where he tries to get the advantage of this collaboration. And again, he places his requirements, and then he try to inform a company where it could be achieved. Yeah, let's take a look at right. So it is the design process is normal, but what we see in the middle is this green bubble is called a data management cloud system. Let's call an individual body. So we have a BIM manager. His role here is to manage the data according to the design needs and the how this data propagation would affect the other engineers. In this example, let's say again, architectural designer produces his designs based on the tool one, and he converts his information into this IFC file format, and then he sends it to the BIM manager. So when this file has been arrived to the BIM manager or his cloud platform, and then he has all rights to send all this information to the next design engineers. So they will simply load this file into their tool systems or their tool ecosystems, and they try to perform design based on the existing data. Once the designs are completed, they again send back this information in the same neutral file format to the BIM manager. And he stores the information, and then it propagates for the next levels. But again, right, so there could be any design changes which can affect the design process. That's where we have this alert mechanism. So whenever a design change happens or whenever a design change is requested, this alert mechanism comes into the action, and then it alerts the all dependent users. So this is a way of collaborating efficiently so that information has been shared to the other engineers on the right time, which can reduces any sort of delays or any sort of a mismanagement of data. In reality, how does this process may look like that, right? So an architectural engineer or an architectural designer models his information here, yeah, and then he export his data into this IFC file format. This is not enough. He had to verify his data is accurate is not or not. So that he uses an existing model checkers. He loads his information into this model checker. He verifies the data, whether the data is accurate, and then the data is complete. And then until he reaches the completeness of the data, this cycle runs. Once he reaches to the a stage where his data is complete, and then he will inform to the BIM manager, hey, you have a data is ready, and the next engineers can take the data and proceed in their design. And the next engineers can simply take the data and then just try to absorb the data for the next analysis or next design process. Yeah, for more details of this process, I try to mention here two different research publications which were published by me and some of the few fellow co-authors. I strongly recommend just to read. Don't worry, at the end of the slide, I'll present you the overall page website for all the publications where they stand, and you can simply skim them. Okay. Right now, we talk about sharing the data, right? And let's go into the next level of the availability of data, right? So we only not have a data in a single format usually. So there are particular ways of data can be comes, right? So for example, as by the previous resource, one can get the point clouds data by performing a scanning of a buildings, and there could also be some data related to the sheets or some of data coming from the sensors, right? How do we manage this data? And again, the solution would be here is in this a cloud platform where you can store your data, which can be any format, and it can be shared to the among the users. But you see the lack here already, right? So you have the data available in the cloud platform, but there is no links among this data. It makes quite difficult for you to see, hey, what file is connected to what file, and how this data integrated to each other, and how a model or how a design evolved to the construction stage. So these are the lack at the moment using this centralized cloud platform. Also, tool compliance, right? We talk about communication among the engineers, but more precisely, when we look into the process, it is more been like a communication among the tools. Tools might be should take the data accurately and process them and then to put into the same format. So this is where the trouble comes, right? There could be some tools which are highly capable of doing that, and some other which may not be capable of doing that. Since these are the vendor tools, perhaps we are not having the control over that. This is one of the criteria we had to keep in our mind. Yeah, when it comes to the summary of these slides, so yeah, we talk about collaboration. Yes, it's definitely improved with the use of building information modeling. And when it comes to the data quality, yeah, we have a manual validation measures through the viewers and validation checkers. And we also have a mechanism for storing the diversified data. When it comes to the data integration, it's still a problem. So because we are not having any integration among the different varieties of data. When it comes to the tool compliance, this is still relevant to a big issue because these tools are all vendor supported. Yeah, the final one, the data extension, exactly. This is not possible at the point of time because this IFC structure has been developed by a particular team, and if you want to extend this data, you had to contact the team and you had to inform them, hey, I have a missing data, and you need to extend your model for me to push the data into the cloud. So these are the additional benefits of the current diversified structure. At the same time, we have still a couple of lackages in this process. Yeah, if I before I jump into the next section, do I ask any questions do you have regarding the background or the need of digitalization? No worries. You can save your questions for the end. We can do that a bit more accurately. I just have one question for you. Perhaps you could answer to me on this background. Right. Do you also think in traditional construction, collaboration is still a problem? Do you also have the same opinion after hearing all the background and the problem statement? Do you have any other opinion on this construction process? Yeah, if you go back to your Mentimeter, you could definitely answer. Yes, very interesting. So I have only one response. Yeah, perhaps I could convince this response in the next slides. Okay, let me proceed with that to the semantic web technologies. So how are we trying to increase the communication or sharing of the data among these tools. So while we are researching different approaches, so we are landed here in this semantic web applications. So where we try to model our information into an ontological format. So let me just try to give a simple example here. So as per the definition, the goal of the ontology here to try to provide the domain-specific knowledge with the help of classes and object properties and some of the constraints. Let's take this information here. So we want to say Anna owns a Toyota car. And this is the knowledge. And then we can also break this knowledge into three different items, like Anna is a subject, Toyota is an object, and which connected with a property owns a. When it comes to a data model, perhaps it may look like this, right? So Anna owns a Toyota. So this is how you indicate information into this ontological format. And you can also add some more additional information, like Anna is a type of a person and Toyota is a type of a car. And it can also have information, a person owns a car. So this is a basic, a generic level of the data. When we improve or when we adapt this information into our building sector, we could also try to think about how can we say that this building has a stories, floor 1, floor 2, and so on. So there are already published researches on this topic. So here is one of the simple example. So we try to indicate a building which is constructed in a site, and it contains multiple stories, and then each story is further divided into multiple spaces. So this knowledge we can put into a graphical format. Here's site 1, which is a type of a site, and connected to a building with the help of this predicate has building. And this building further categorized into multiple stories, which is a floor 1, floor 2, floor 3, and which again are the type of a story. And then these further is try to indicate what kind of rooms these stories are comprised of. And then you see the floor is further divided into different rooms. You can also mention the information about, hey, these rooms are adjacent. With this predicate, we want to say, hey, these are adjacent zones. And then these two rooms are the type of also spaces. This is a simple example, and which we want to try to say here was like site 1 having a building A, and this building has 3 floors, and floor 3 has 2 rooms, and these rooms are adjacent to each other. So this is one form of representing the information. So the only idea here is like working with the data would solve the data exchange problems. So it is completely the data organization specific. So one can use the own way of modeling their information, and at the same time they can follow the already existing ontology schemas to achieve that. Let's jump back to our example model, right? Let's take this building. So we want to say this building has a site, or a site has this building, and this building has a single story. I know it has multiple stories, but I just want to indicate with a single story. Perhaps this is how our model starts looking like that. And let's just take a look into each of the issues we had seen in the previous background section. So let's talk about the data extensibility. Perhaps we have a very large building here, and we don't want to construct this whole building at the same time. Due to it could be many reasons. You want to have same elements in the same phase 1, so that you can just rent only these specific scaffoldings and so on, or you can model, or you can produce some specific set of elements out of that. Yeah, in that case, so one can easily segment building into multiple segments, and then they want to construct this part and this part of building in the first phase, and then remain parting of the building in the second phase. So how does that affects our ontology or our model, right? So we see that site has a building and the building has a story. Now we want to extend this information into segments. So we can easily extend our model into a building segment, so which is connected to a building by using this property has segment. And this building segment is further connected to a story with the help of has story. So this is the very easily extendability your model. I'm showing it to a very low level, but it could be much more complex when it comes to modeling all the building data. And as I said about the collaboration previously, we had very improved collaboration with the help of BIM, and it is the same. It can also increase through different people and different data sets. Before we are working on a file-based data exchange format, but now we are trying to move out from this file-based data to the data-oriented, where you have an architect produces the information about your building elements, and your structural engineer comes with the construction details, and your simulation engineer puts the data about simulation, the information, and your contractor is also trying to provide the details about existing information about materials they have. And all of these can be connected, interlinked with this simple classes and object property connection. So one can easily track the changes, and one can easily try to understand the information that's stored in these sectors. And when it comes to the diversified data, right? So as I said that I tried to show a simple example here. So one can easily scan an existing monumental buildings, and they try to produce a view out of that using any kind of LiDAR scanners and so on. And this produces the data in point clouds. And these are the data information from the sensors, which are tracking the information from the building, sensing the information out of the consumptions, and some of the information about the material data. So we can see what materials you use for this building. And as I mentioned earlier, you can also have information about your building model. What is the space you have, and what wall element is beside what room, and so on. And in addition to that, you could also have a weather data just to compare with your building performance data. So in this case, how do you link this kind of different data sets? So again, extending our information model with the capability of linking these elements. So we will extend our ontology schema. Let's say we have a link element, and it connected to a link, and we can have multiple directional links. It can have a one directional link, it can have a n directional link, and so on. And not to the model, but if you look into this example, right? So you see, let's assume we have a different data sets. We have an IFC file where it tries to indicate the architectural information. We have an existing device information. Oh, okay, this is a device placed in your building. And we also have another file format, which is a PDF, where it try to describe about your drawings information. And another file information about, as I mentioned, the ontologies, where your data has been linked to each other. It's a data model. And the other information about a precast library availability. So when it is readied, and when it has been transported, and when it has been placed, all this information has been in this document. Through this your link model, you can link what file, and in this file what identifier has been linked to the what other file in the same repository or in the same cloud storage. And this will provide you the additional knowledge of this information. For example, in this IFC file, you're looking for this wall, and then you see that also the information, hey, this wall has a real image, and it also describing the equipment it's connected to it. And at the same time, you could also see that this wall section is a PDF, and you can see this PDF is from a wall section, and then it can be connected to a specific wall element. And you can also see how the cross section of a wall and what information it has and so on. Again, a much detailed information about this linking mechanism has been presented in this paper. It would really navigate you to the much more details in that. Yeah, let's jump into the next additional benefit of having these data models. So one can easily utilize representing the standardized concepts like level of details and so on. So perhaps you might have been heard about this USA LOD framework. So you can define your design models into these different levels, which varies from LOD 100 to LOD 400, which is indicated to define your design. And also you have as-built information where you have LOD 500 information. So with this, the new way of defining your data, you can easily put your standardized concepts into that. Yeah, let's see an example how I translated this LOD framework into this data. So we have a USA Beam Forum framework, and then it has levels as design and as built. And as design is a previous level, and as design has next level as build. And you can also see that it contains a sub levels, right? So this design may varies from LOD 100 to LOD 400. This as built is indicating the LOD 500. And they also have a relationships between among them, right? What is a next and what is a previous. So if you see that the knowledge what we can read from a PDF document, or a knowledge what we can read from a standardization, it can easily be converted into these models, and you can apply your data into that. I can show you in the coming section, I can show you an example how we are converting all this information into a rule-based mechanism by modeling the information in such a format, because we are converting the human readable information into a machine readable data with the utilization of formal semantics. Again, much detailed information about this research has been presented in these two different papers, where we are talking about both the LBODs and at the same time BIM stages, building lifecycle management stages as well. Yeah, if we can see a simple example with respect to this standardized concept, right? For example, here we want to talk about a wall, and its label is basic wall, and it has an ID, which is quite normal to have any information about a wall. And with this predicate has property, you are connecting a wall to a property instance. And the property here, what is connected is a width property, and it is having two different states. And these states are linked to this property using this has property state predicates. And each of this state is connected to one of the LOD levels. For example, this state is connected to LOD 300, and then the other state is connected to LOD 350. And this is the information we already have in our model, because it says that LOD 300 is usually have a next level, which is LOD 350. And if you see what this property states having, these property states having a label which indicates a width, and it also shows a value for that specific property in that LOD 300. In similar to that, in this property state, this is also same label because it is going to be talk about the same property, and it shows the varied or improvised information or a design change here. And this is linked to this next level. This is how we track any design change propagates into our data. Yeah, so until now, previously we talked about files, right? Architecture creates this model, and then he puts his data into an IFC file, and the other engineer takes this IFC file, and so on. But now when it comes to this ontology modeling concept, these ontologies are data-based concepts. So everyone needs to push their data into a repository or a central cloud-based platform, and everyone needs to extract the data from that. So let's take an example on how one can take the data out of this available, right? So we have a defined query language for that. We call that Sparkle, which is a Sparkle query language. So its goal is to extract some of the information out of the existing graph where some patterns are matched. So this is called a conditions, when some condition is matched and they just give me this information out. This is a very standard form of querying any of your data. So what do I mean by a pattern, or what do I mean by a standard here, right? So let's take an example, and one more time we are going to our model here. So we have a site which is connected to a building, and building has been divided into multiple segments in a horizontal way, and also building having multiple stories, and each connected to its segment as well. So here is a query pattern saying that a subject, which is unknown, is connected to an object, which is also an unknown, through the predicate has building. So this is a pattern. Whatever matches to this pattern will output as a result of this query. When I run this query in a specific run engine, so it outputs me that the subject is a site and then object is a building. So you can also extend this query patterns line by line. So this is a first pattern, and the second pattern extending this object. So this here is an object. Also, we don't know what is that, and it connects to the specific P, and which also don't know what is that, and then through a predicate called has story. So when we run this query according to our data model, you could see that it outputs the information about the site, which is a subject, building, which is an object, which is indicated with O, and the story, which is indicated with P. So this way you can extend your patterns to the much more higher level complexity, and you can get your data output, and you can feed this data to your tool as a input, and then you can run your or you can generate your designs. Yeah, as I showed you in the previous example, we had provided links between these data models and how can we query this information out, right? So this is a bit enlarged query, and this query results the following items. It is resulting a document 1 and a document 2, which having a connection. Let's look at this, right? A building material.rdf file is connected with wall some JPG file. So if you see this link 3, so this is what it is trying to explain us, right? So this link 3 is providing a connection between this image to an RDF file. This same information you will have in your database, and then through your Sparkle search engine or a Sparkle query, you will get this data out, and then you try to use it for your analytics or next design processes. Yeah, you can ask me about like how do I make sure that my data is valid? How do I make sure that my data is accurate? For that, we have a new technology called shape constraints language. It's really a funny image you can see. So one can define the shapes and which are should be validated, right? If you assume this is your data, and if this data fits into any of the shape which you define, and your data is accurate, and then your data can be pushed into your data source. Yeah, let's take a simple example here again, right? So again, we have this our sketch or our building model. We say that site has a building, and this building is connected to a building segment, or a building is connected to a story, and so on. So the first constraint I want to ask, like building must have a story. This is a shape, or this is a constraint I define in the database level. And now someone pushes the data to the database, and this constraint come into the action, and it says that yes, this is accurate. A building is connected to a story. Perfect. And the next constraint it checks, right? I said here this constraint story must have 4 spaces. But when it try to check about this information, it fails. It shows as a validation failure. It says that, hey, you have a story, but it is not connected to any of the spaces. So that is the reason your data is not valid, and it cannot be processed to the next design progressions. And you can also apply in such way. You can also have many of such constraints you build on top of your data. Yeah, we also talk about tool independency, right? So before having a tool dependency is one of the difficult situation where you had to regenerate your data. But here in this case, you just need to define a converters by yourself, right? So you will have a data in your database. Any simple converter can take this data and then push you to a different files what your tool accepted. And in the same way, you had to push the data back to your data platform or a database. And this is how you will make your infrastructure is tool independent and try to take the advantage of having this independent structure. Yeah, just to make sure rewritten or rethought about our summary here again. So yeah, we are using still the building information modeling, and it is an improved collaboration. Yes, when it comes to the data quality, it has been improved through the automated validation. So one can just one time the right shapes, that's enough. And the diversified data, exactly. You store the diversified data in the database, and then you try to interlink this diversified data using the classes and properties or predicates options. Yes, it is irrespective of any of the tool. You had to convert the data according to your data tool file format, and also it can be readily extensible the way how we extended this building segment concept to the building. Yeah, I think we reached to the end of the second section. Do you have any further questions or any other doubts you have on this section? As I mentioned, you can save all your questions to the end of the session and you can place it at us. Yeah, if you don't have any question, maybe I can share this interactive slide what I prepared. I hope you guys still there to answer this. Good. So on the ontologies, maybe based on the current slides you had seen or a current lecture you had gone through, do you think this can be a potential solution, a database solution? I know one of you disagreed previously about a problematic data diversified, but sure. Yes. I go proceed forward. Thank you so much for your response. It's great to see some of you are really interested in trying to answer the questions. So now I want to take you to the digitalization in practice, right? How are we using this ontology technology and what kind of advantages we are gaining out of that? Before I jump into this the specific section, like I just want to give you a use case. This is exactly what we are doing at the moment in our factory. Perhaps it might be interesting to you. So we have approximately 500 meters long a production line. The goal of this factory is just to produce wall elements and the slab elements with the timber materials. And we have approximately 45 robotic arms. Their job is to take the raw wooden pallets and try to convert them into beams, the walls or slabs according to our design. Excuse me. Great. And then we have a 12 automated guided vehicles. We call them AGVs. So the role of these AGVs here is to transport the raw wooden pallets from storage locations near to the robotic arms. So they take the information. These robotic arms takes the raw wooden pallets and then place them according to that. So once this has been done, completion is a production, and then these elements can be stored in a produced place, right? So we have a capacity approximately to store 240,000 square meters of area, and you can just put them into it is just an exaggerated number, so it can be something like a 34 soccer fields. And when it comes to the construction and assembly, so you have autonomous crane systems. So you just place these wall elements and the slab elements according to the design with the help of these crane systems. We could also have a simple pots for the bathrooms and the kitchens. You can just simply place them. You could see the degree of automation here. It's approximately 86%. So we have a very manual interactions with these robotic arms for this production, but still we have a little bit manual. It needs a little bit of manual support. And if you see the degree of fabrication, it is up to 80%, which means that a wall which comes out from this factory, it is almost 80% is done. What is remaining is just having the connections with the other walls, and this factory, they also places the electric sockets into the walls. So one simply needs to give the electric connections to these sockets or lights which they are placed in the lamp in the slab positions. That's the reason we say it is only 80% prefabricated. Sorry, let me go to the next slide. So what we do in our buildings, right? So it is very normal process, right? We plan our buildings, and once our planning is done, we produce with the help of these autonomous robotic arms. Once the production is completed, we transport them into the construction site, and we try to assemble these produced elements at the construction site. And once they are done constructing, as I mentioned, that we also have sockets and a lot of sensors embedded into our walls and our slabs. So these sensors will producing the data, and we try to record this data, and then we gave them the operational instructions. Well, we can dig a little deeper into our process. So this is planning. So we start with starts with the layout planning. So let's say again our Bob comes with his requirements, and we try to put these requirements into our rule-based engine. As I mentioned, that it is a very autonomous and a powerful engine. You just need to give your site layout into this tool, and then this try to generate based on your requirements, like you need to have 4 floors, or you need to have single room apartments this many, or you need to have multi-room apartments this many. Based on this information, the tool generates the layout. Once the layout is completed, the next stage of the design starts. So the next stage of design is almost like a structural design. So we call here parameterization. So based on the length between the 2 different supported beams or 2 different supporting walls, how many layers of wood you need to put for a load-bearing wall, and what are the other items, if it needs to have an opening, or if it needs to have a window, and where it should be, and what is the dimension. All this information has been designed in the next stage of the process. I tried to come up with a simple video from this. Yeah, maybe it is playing. As I mentioned, it is a completely autonomous process. And this is, you just need to introduce your site layout, and then it automatically suggests you what kind of building structures you want to have in this site. So you can adapt according to that. And this is a single tool, it works, and then it gives you the more of the information. I hope you had seen this video. I hope it played. Sometimes these videos are not played. Just write me in the chat if this video has not played. And once the design has been frozen, now it goes to the production. So we have, as I mentioned, that we have so many robots in this factory. So the goal is to produce these designed slab or wall elements in a sequential order, and they goes to directly to the construction site and assemble them. Yeah, this is more or less it tried to identify what type of the elements we want to produce, and what is the number of these elements. And if you see that it, based on this information, it takes the raw material. For example, it breaks down each of the elements into what it needs to be built with, and then it starts to construct each layer and by placing on top of that. And many robotic arms has many jobs. So some do the suctions job, some do the guns. They have nails shooting into the wall fabrics, so that to make this intact, and everything has been properly designed. And the next step is construction. Once the design and the production has been completed, so they moved to the construction site based on the schedules, so based on the site condition. So there is no storage in the site. They just take out from the vehicle and then place it, and then they complete the construction process. So perhaps in this video, I try to indicate that. So once the design has been frozen, so they prepare the initial site, the ground floor, and then whatever is produced in the industry, they goes directly to the site, and they had been assembled there. So there is no storage. You don't need any additional support in the site. You don't need an additional mechanism to indicate where does it goes and so on. And again, everything has been intact. As I also mentioned that we also have a lot of sensors built into these wall elements. The job is to sense the data. So what is the consumption? What is the heat consumption in a specific room? What is the energy consumption in a specific room? And we try to push this information as a notification to the tenants so that tenants will be aware of what they are consuming, and they try to reduce their consumptions in such a way they try to produce the efficient energy consumption results. At the same time, we do this device management, security management, and if a device fails, and we try to get that response immediately, and then the repair can be done, or a replacement can be done on the immediate spot. Yeah, for this whole process to be work as they planned, so the heart of the ecosystem is the data. So it's more precisely, how are we handling the data properly, and how are we gaining the data or gaining the knowledge out of this. So this is where we come into the picture as a data or a knowledge engineers, having a knowledge about construction, and at the same time converting the construction standards or construction knowledge into a machine readable. This is what our job. Maybe I try to give a simple scenario here, so to compare how this design process goes. So this is a layer called a data fabric or a data source, let's call it. And then we have the ontology models, which indicates how the data should be stored. And there is another external data storage mechanism. Sometimes you cannot convert all the data into these ontologies, right, into a very data. So you could also store this information into a different file formats. That is also definitely possible. And when a design layout has been freezed, or an architecture designs his information about building based on the requirements from the user, and this information has pushed to this data fabric where we have the defined architecture there. And once this design layout has been freezed, and the next one is the design for the structural part. And the structural engineer takes this information, he models and he designs his information, and then he will send it back, his feedback. And the next process is a production, and the production engineers takes the information out of that, and then they try to tell us what parts are produced, and then what is the number of parts and which part has been produced. And this information is continuously feedback to the data fabric. And at the construction site, the people will consume this data from the construction site, and they try to assemble the information or they produce as elements according to the placement they get. And they report back, hey, we got this material and we placed it, and then this construction is over. And that information has been stored again in the data fabric. And in the end, what comes is the operation. So the operation people will take the data again from the data fabric, and they try to understand what are the consumption measures, what devices are placed, what devices are having troubles, and all this information they will send it back. If they also replace any device, they will put it back, this information, into the data fabric. I think this is the complete loop of the operation in our organization, and it completely based on our data fabric setup, and the information has been stored into data sites and the external file formats. Along with the storing the data, we will also generate a lot of business operational insights. So we try to render what parts of a building has been constructed. We try to see how many elements have been produced in the industry, and how many elements are completed in the placement, and much more information about where they are producing and what is the area of this information, and so on. So all this insight we are produced, and we are placing it to the top level organization structure, so they could understand the running process. Yeah, I mean, we're also doing these validations, right? So you had seen data pushing, right? Whenever a data pushing into the data fabric, we have an intermediate layer. This is where all the validations has been performed. So we define a lot of constraints. So once the data has compliance with these constraints, then only it pushed to the data fabric. Otherwise, it's sent back to the producer, and producer need to make sure that he produces the data according to the compliance, and then he has to push back to the data fabric. Yeah, as a short summary on this side of the practical application, how we are using. So our role here is to define models, which are ontologies, and they also define validations. So we use them before pushing the data to check whether data has been accurately defined or not. And we also define some query templates where someone can use them and to extract the data from these data sources and the data fabrics. As you see that we also define some insights from the data, like bill of materials, we say a production plan, and we also design an assembly plan out of this existing data. Yeah, again, perhaps do you have any questions on this this process?
Yeah, Mr. Jankiram, I have a question.
Great. Yes, please go ahead, sir.
So regarding this assembly of these elements, you said there is no storage in the site. All the elements are being assembled and then next floor like that. So
That is
how would
right.
they plan these elements? Because one particular, suppose you have a long wall, which is required for all the floors, right? So, but in the same floor, one long wall, maybe one short wall, one wall with opening like that, they are required. So they are brought according to the requirement like that. So how would they manage
Ex
the production and
exactly.
transport?
Exactly. So every wall element has had a property called position code, sir. So this position code indicates that at what place this wall needs to be placed. So based on this position code in the factory, they put, for example, we want to construct, maybe I can show some sort of examples. Yeah, maybe later at the end I can show that example. For example, we want to construct one side of the building, and then this, based on the position code, the production starts. Whenever the moment the production is completed, they transfer this immediately to the site, and then they place this element. So these walls are only limited to the stories, right? So no wall can goes to the over the stories. So this stays at a story level, and this is a highly communicated structure there. So based on this position code, they transfer the data to the site as well. I hope that answers your question, sir.
Yeah, that's fine. But the production of multiple elements at the factory will be advantageous for them rather than different components of different sizes, different properties like that, right?
Exactly. So it depends on how many buildings are constructing at a time, right? So it could be many more buildings are started construction at a time, so that the production could be more. Yeah,
Right.
and then they had to store according to that.
Right. Thank you.
Yeah, thank you so much for the question. Yeah, I do have one small question. Maybe I can place it here. Great. So I just have one for this autonomous construction. I hope you still have access to this. Yeah, maybe you can just type your thought. What are your thoughts on this autonomous automated construction? Maybe do you see there is a future for that? Do you see a lot of complexity in that? Yeah, maybe I just mentioned, I forgot to mention that our goal is to construct a 4-floor apartment in a span of 30 days. Due to the lack of labor and many other reasons, we had to adopt this autonomous construction process here in Germany, especially in European countries. Yes. No worries. I can go to the final section of my presentation. Yeah. Yeah, I just also want to touch a sneak peek on AI insights. Yeah, but before I go there, it's a kind of very natural data. I cannot brought back very efficient organizational information here due to the data privacy, many reasons, right? So What we are using right now is a graph rack. What one can definitely use this technology on data information and the knowledge graphs, right? So RAG is generally abbreviates for Retrieval Augment Generation. It works on our large language models, which are ChatGPT or Olama, Lalama, any large language model, and it connects to the external sources of information like our building data. So these large language models are having the information about the nature of the society and all the information in the site, but they may not have the information about a building which we are going to be construct. So this is where we use the retrieval augmented generations to connect the existing information with the external information. In that case, we have a new technology has been implemented, which is called a graph rack. So we connect knowledge graphs or ontologies, what in the previous slides I showed you, with these external sources. So it is something a simple an image which are generated from this GraphDB resources. You try to utilize these capabilities of a large language model, and you connect this large languages model with your data. So the data which is coming from the knowledge graphs, yeah, which are this is a called a GraphDB resource, database resource. So what is our goal here on generating the data or connecting to this graph racks, right? So we want to generate a more meaningful data from regarding our buildings, and we want to gain the advantage of generating the reports, or for example, bill of materials, or we want to gain the advantage of generating the information on storing the information on current building and applying this knowledge to the building which we are going to be generated in the next sessions or next days. So we want to get more expandable or explainable reasons from out of that. Maybe here is one of this example which we can see. So we have a GraphDB, and then you can connect through this ChatGPT retrieval plugin through a Lalama or a ChatGPT large language model, and you can simply talk to your data model. Here is one of the simple video clip. You can do a natural language search. So you can ask the model, hey, show all the walls presented in this model, or you can much more ask like, I want to see the slabs, or I want to see the windows, and while it is generating in the process, maybe you could also see in the bottom, it generates the natural, it converts into the Sparkle queries, and then the results also it can be produced here. This is one of the advantage we could get out of having the connection to this large language model. Yeah, also maybe one more example. This is what I mentioned in the previously, right? So this is our model, a simple model. And then you can ask directly these questions to this model, how many stories in the building? You can just phrase your natural language questions. And then the database, with the help of this large language model, is try to respond you in the same natural language process. You have one story and how many walls in a story one, and give me the total wall length. It know how this is what it knows, how to sum up the lengths, because it has that knowledge from the external sources, but you're trying to give what is the length value from your graph. So then it takes that information and then it try to give you these immediate responses. You can have a communication with your data model as you talk to your ChatGPT language model. And you can also ask a few more questions like, are these single doors in a building, or a few other more such a type of questions. Yeah, I reached to the end of my presentation. Just I thank everyone really for having your patience and helping me to provide this long lecture here. Yeah, I especially want to take this chance to thank a few of these team members, especially Satish sir and Santisagar sir and Anil sir. So they were guided me in the all this process. They helped me and they try to navigate and they try to understand the process and take to the further steps. Yeah, definitely. So the team under the curtains, I know it's a long process, and then you might have been helped each other, and I thank you really, everyone, to make this happen and to take me to this further. Yeah, as I mentioned that you can follow my research under this research gate, and I have approximately some 24 research publications, and you can find the link in the research gate, or you can directly go to this research gate and sign it with me and search my name directly there. I would recommend try to reach out me if you need any suggestion or any help on these publications. I try to make all the publications available to the public. One can easily read and see how it could be helpful for you. Also, yeah, you can recommend my publication if you like. Yeah, we have reached to the end of presentation, as I mentioned. If you have any further questions, I'm happy to answer. Anything related to the industry or to the research, even whether in Germany, anything you would like to know. Yeah, if you don't have any questions, again, thank you so much for your patience. Yeah, I see we are a bit ahead of the expected time. Maybe if you have any further announcements, Anil, you could use the floor for that.
Thank you, Jankiram.
Yeah, thank you, sir.
Very good
By the way,
interactive
nice.
session.
Yeah, thank you so much. And by the way, nice to hear you. It's been very long.
Okay, thank you very much.
Yeah, no worries. I could be here for another 10-15 minutes. If you have any doubts, I'm happy to take it. If you have any other interactions, or if you want any other doubts, you can also place regarding your evaluation process or something like that.
I just want to congratulate you, Mr. Jankiram. Having studied in Babadla Engineering College, again coming back as a resource person for FDP, it's a wonderful opportunity. Thank you for the session.
Yeah. Thank you so much. I do feel the same. I am kind of blessed to have this wonderful opportunity. I must thank Sant Sagar sir just for pushing me to be here and today to share all this research knowledge with you. And I wish you a wonderful day, everyone. I hope you have a good time going through all these presentations and seeing the various research fields in the civil engineering domain. I felt amazing by seeing the LiDAR scanners in the previous session.
I think no questions from the audience, Mr. Jangram. So thank you very much for your good session. So we would like to continue with the valedictory section next. So participants, we request you that the valedictory will be proceeding in another 5 minutes. So please stay ahead. After that, we'll be giving you the remaining details of the how to get the certificate and the ATL and everything after the valedictory function.
Yeah.
Mr. Jankiram, thank
Perhaps,
you.
yeah, I will drop out. I wish you everyone have a good time. And once again, I thank you, the Bapatla Engineering College, for providing me this wonderful opportunity, and at the same time created this atmosphere to learn and share our knowledge among us. Thank you so much once again.